composites. So if we come back up to composite areas, composite centroids, it's the same equation. So instead of using a continuous integral, we're using discrete sums. And instead of this guy, we're using just the total lengths of all the areas. So really basically the same equations. Example problems. This is a pretty complex example. But I like to, when I'm working these problems or teaching students for the first time, I like to set up a table like for the first time to kind of formalize the thought processes. And so, and what you're going to have on your test is they'll give you a composite shape, but they typically, well, no, sometimes they do. It's never this complicated. I mean, it might be, I mean, this has got like a half circle, a hole, a rectangle, and so these are 4 different shapes. This is way too complicated for a single problem. But for the centroid problem, it could be like 2 pieces, you know, like a rectangle and a half circle, or a rectangle with a hole in it. And so what I do is I number the areas or indicate them in some way. And so I call the half circle 1, the hole 2, the rectangle 3, and the triangle 4. 2 or 3 of you can work the same problem and break it up differently. So there's not one way to do this. For example, one of you might take a whole rectangle here and then subtract off a triangular hole up here, whereas somebody else will take this rectangle and then add the triangle to it. So there's multiple ways you can do it. So decide on your areas. I draw a picture of them. Calculate the areas. So you get an area of the half circle, the area of the hole, but for a hole, the area is negative. The rectangle, you get its area, and then the triangle, his area. And then I find the x tilde for each of these shapes. So the x tilde for this half circle is negative, because I think the y-axis is, yeah, that's the y-axis. So the x-axis for this guy is the 4r over 3 pi. And so it's 4, the radius times 100, divided by 3 pi. And it's negative because it's to the left of the y-axis. His y tilde is just 100. For the hole, the x tilde is 0 because it sits right on the y-axis. The y tilde is 100. The rectangle, his x tilde, this is 250. So the x tilde is 125 and the y tilde is 100. And then finally, the triangle here, his x tilde is 250 plus 1/3 of this. So 350 minus 250, this is 100. So 1/3 of 100 is 33.3 plus 250 is the x tilde. And the y tilde for the triangle, so this total height is, if this is 100, this is 100, and so this is 200 high. And so the y tilde is 1/3 of 200, which is 66.67 is that guy. And so once you identify all of the areas, all of the x tildes, all of the y tildes, then you just sum the xa and then sum the ya. And those give you the numerators. And then if you sum the areas, that gives you the denominator. And then you can find the x bar is the sum of the xa's divided by the areas. And then the y bar is the sum of the ya's, the y times a's divided by the summation of the a's. And so early on when you're just starting working these problems, especially a complex problem, I think it's easier to set it up as a table. Once you've done this a time or two, you don't need to do it. But questions on that? That's the procedure. And so you just need to be able to deal with all of the different shapes. So those are areas. Sometimes there's line centroids or even solid centroids on the test. And so I didn't do any line integrals or solid integrals in our examples because there almost never is an integral of a line or integral of a solid on the test. So I didn't cover them in this review. But for composite shapes, it's not uncommon to look for the composite centroid of a line. And so this is a shape in the XYZ system where you've got a half circle here, a straight line here, and a straight line here. And so now you're looking for the length of a line. And so the length of the line is their circumference. And so this is pi times r is that length. And then this is 40, and this is 20. So those are the three lengths. Now the centroids are, for a line, is 2r over pi. Yeah, 2r over pi. And so the centroid of this guy here is negative, in the negative y direction, it's negative 2r over pi. The x is 60, and the z is 0. For this guy, the center of that line is 0 in the x, 20 in the y, and 0 in the z. And the centroid of this guy is 0 in the x, minus 10 in the z, and 40 in the y. So once you get the three lines, then you can just sum the sum of the lengths to get the total length. The x tilde is the sum of the x tilde li over lt. The y tilde is that sum, and the z tilde is that sum. And you end up with a z that's slightly negative, because the half circle lies in the xy plane. This guy lies in the xy plane, but this guy is below the plane. So the composite centroid in the z direction is slightly below the plane. And so one of the things you need to do on any problem that you work is to be sure that you keep your senses about you as to what a good number is, to make sure that this number makes sense. So that's a line centroid. I don't think a solid example is common, but a line centroid is. So I won't go through this. So you've got a solid here, but it works the same way. Questions on composite shapes?